In this video, we're going to look at the basics of factoring, and specifically we're going to look at a strategy called factoring by grouping. So we need kind of this prior skill before we can jump into factoring by grouping, and that's factoring out the greatest common factor when you have a polynomial. So here we have two terms, and what we're going to do is we're going to try to look at what's common in the two. I'm looking at what's common in the constants, or excuse me, the coefficients, but I'm also going to look at what's in common in the variables and their exponents. And I'm going to try to factor that out, or as I call it, undistributing it. And so whenever I look at this, we've got a 9 here, but there's like an invisible 1 here, so there's not really anything in common with the coefficients. So let's look at our variables. And so when I look at w to the 6th and w squared, I'm going to say what's in common there? And hopefully you're saying what's in common is w squared, okay? That means that both of these two terms have a factor of w squared, and I can factor it out to the front. It's like I undistributed it. It's like I went back in time to before I distributed a w squared into something to get this. And so now I'm just thinking, okay, well, what's 9w to the 6th divided by w squared? Or you can think of it as w squared times what gives you 9w to the 6th. And hopefully you're saying that's 9w to the 4th. And then what's w squared divided by w squared? Well, that's just a 1. So this would be the factored form of this binomial that's up here. And if you ever weren't sure if this was equivalent, you could just distribute that w squared back into the parentheses and see if you end up there. Now let's look at the next example. In our next example, I'm looking at 3 terms. We've got a trinomial. And so first let's look at what's in common out of the coefficients. Okay? When I look at the coefficients, they're all even. And so I'm immediately thinking maybe it's a 2, and I believe that's going to be our greatest common factor of the coefficients. So let's factor a 2 out. Okay? And then let's look at the variables. You might see, okay, we've got an x squared and an x, but there's no x here. So x cannot be a part of our greatest common factor. But it looks like they each have a t. So let's factor that t out as well. And now I'm just going to take each of these terms and identify, okay, what's left if I divide out a 2t? And for this first one, it's going to be 3 x squared. Because if you were to multiply 2t times 3x squared, you get that. For the next one, it's going to be 4x. And for our third term, it's just going to be 6. And I'm getting each of these values by, I'm thinking of it two different ways. I'm thinking, okay, what is 12t divided by 2t? Well, that's 6. Or I could think of it as 2t times what gives me 12t. So there's our second one. Let's do this third one. The third one's kind of a crazy example, but it's going to help us for what we're learning later. Not in this video, but in a later video. Well, look at these three. Let's look at the coefficients first. I can see all those coefficients are multiples of 7. So our greatest common factor of the coefficients will be a 7, okay? But whenever I look here, we see that I have this m plus 1 cubed, m plus 1 squared, and m plus 1 to the first power. Think of that like x cubed, x squared, and x to the first power. So what I'm going to do is I'm actually going to factor out the value of m plus 1. Because that's still some number. We don't know what it is, but it's some number that we can factor out like normal. And let's identify what's left. 14 divided by 7 would give us a 2. M plus 1 cubed divided by m plus 1 would give us m plus 1 squared. Let's move on to our second one. I have negative 28 divided by 7 would give us negative 4. And then we had m plus 1 squared divided by m plus 1 would leave us with m plus 1. And then our last term over here, we have negative 7 divided by 7. That's going to leave us with minus 1. And then m plus 1 divided by m plus 1 doesn't really leave us with an m plus 1 there. So there's your last example. This example is a little bit tricky. I just kind of want you getting used to seeing problems like that. But we might look at more of those in a later video. Now, we've got that. This is like a background skill that we need. I know I've been like 4 minutes just on this background skill, but let's jump into how to factor. So, to factor 8x cubed plus 13x plus 5, what we're going to do is we're going to break this middle term up into 2 different terms. I need to find 2 different terms that add up to negative 13x. We don't know what they could be. They could be negative 10x and negative 3x. It could be negative 16x and positive 3x. It could be anything, but we need to add up to that negative 13x, but we need those same 2 numbers whenever I multiply them to give me 40x squared. That's how we're going to know the right combination. If you're not sure I got that by multiplying the first term times the last term. Okay? So now I'm thinking about this. I know my numbers multiply to give me a positive. So they're both negative or both positive. And since they add to give me a negative, I know they must both be negative. And in this case, it's going to be 8x and 5x, both negative. And so that means my middle term, I'm going to rewrite it as negative 8x minus 5x. I'm going to bring down my 5, and I'm going to bring down my 8x squared. And now we're ready to group like we were doing on the last slide. I break that middle term up into two different terms, so I now have two groups of 2. I'm going to factor the GCF out of that, and I'm going to factor the GCF out of that. So here, the GCF of 8x squared and 8x is going to be 8x. And we'll factor that out, that's going to be with x minus 1. So it's like I undistributed an 8x out of both of those terms. And I'm going to come and do the same thing over here. I've got a 5x and a 5. What's in common between those is a 5. Since this term on the left is negative, I'm going to factor out a negative 5. And that's going to be with x minus 1. Now if I look right here, in the same way that we factored an 8x out of these two terms, and then a negative 5 out of these two terms, I now look at this like this is a term and this is a term, and what's in common between those is the x minus 1. So I'm going to factor that x minus 1 out to the front. I'm treating this entire x minus 1 like it's a value, just like an x. So if I factor that x minus 1 out to the front, I'm then left with 8x minus 5. And so if you weren't sure if that was the right factorization of this trinomial, you could always just multiply those back together with distribution. I think you'd find that it's right. Last example. For this one, we're going to do the same thing, but if you notice our terms aren't really written in the correct order, we want to write our terms in order of descending degree. So I'm going to rewrite it as 4x squared plus 16x plus 15. And now what we're doing is we're playing the same game as last time. I'm going to look for two numbers that whenever I add them, they give me 16x, but if I take those same two numbers and multiply them, they give me 60x squared. I get that by multiplying this first term times the last term, the quadratic term times the linear term. And so if you're looking at this and you're thinking, okay, they're both going to be positive because they multiply and add to give you a positive. So if you think of factors of 60, the first one that pops into my head are 10 and 6, and I believe those are going to be the ones that work for this situation. So I'm going to take that middle term, I'm going to break it up into 10x plus 6x, and I'm going to bring down my first term, and I'm going to bring down my last term. Now we're ready to group. I look at my first two terms, I'm looking for what's in common. The GCF between 4 and 10, between our coefficients, would be a 2, and then, oops, I need to give myself a little space, would be a 2, and then these both have an x in them, so it's going to be 2x will be our GCF. Whenever I do that, that's going to leave you with 2x plus 5 in the parentheses. And let's play the same game over here. I'm looking for the GCF between these two. They don't both have an x, but if I'm looking at 6 and 15, I believe those both have a factor of 3. So whenever I factor that out, that's going to leave me with 2x plus 5. We know we're doing good because that matches that. And so this becomes now, this 2x plus 5 is like our big factor that we can factor out to the front. So I'm going to bring that out to the front, and that leaves us with 2x plus 3. So here is our factorization of the polynomial up top.